Hey guys, my name's Pranjal Gupta. I was a student at Auburn High School and now I'm going to be a freshman at Vanderbilt. In 2011, I was the winner of the Alabama Junior Academy of Sciences paper reading competition. And the project I did was titled A Better Anti-Cancer Drug, Superior Topoisomerase Inhibition by DNA Intercalation with a Mitoxantrone Analog. And basically what it was I took an existing cancer drug, I put it on the computer, and then I modified it in order to make it better. And so basically the whole process of this project was really similar to any other science fair or any other science competition that you've done that's involved research. First of all, I had to think of a topic, and so basically I came up with the topic just by reading through a biology textbook because I knew I was either going to do something in biology or chemistry because those are two of my favorite subjects. And so I was just flipping through a biology textbook or chemistry textbook, and there were lots of interesting chapters that appealed to me, and one of them was cellular biology and specifically DNA replication, and then there was a blurb about basically how cancer is formed, the role of the protein topoisomerase in this whole process. And so that sort of got me thinking about possible science fair projects and paper reading projects. And so what I did after that was I just Googled topoisomerase, and I just started reading scientific papers and Wikipedia articles, just really basic stuff, just trying to get my mind around what this really was. While I was doing that, I had absolutely no idea about what my project really was going to be about. I was just doing simple research, and that's basically the first step to any science project. Just plain research. You can just sit down on a computer and start Googling and just follow links and links and links and try to gather as much information as possible and maybe just take some notes. And so then on one website I think I came across the term computational modeling or computational molecular modeling, and so that got me interested on that topic, and then I started researching that and Googling that, and so then I started to realize that I could link these two things together. Computational modeling, which is messing with chemical structures in the computer, and then this drug topoisomerase. And so with all this research, I sort of started getting big ideas about what I could do, molecular modeling and topoisomerase, and then with topoisomerase I learned about a popular cancer drug, mitoxantrone. And so with all this going on, I sort of decided that maybe I'll play around with molecular modeling and these proteins and see what I can do. You know, at this point I really still didn't know what I was going to do. I was just basically messing around. So what I did was I downloaded a DNA strand from the computer and put it on the molecular modeling software, and then I downloaded the mitoxantrone drug. It's a cancer drug. It mostly treats leukemia and breast cancer, ovarian cancer, and so they have all these structures online on popular websites. And I downloaded them, put them on the software for molecular modeling, and then I just sort of started playing with it and seeing how these two structures interact, the cancer drug, and the DNA strand, and just how they fit together. And an interesting thing that the software gives you is the binding energy between the two structures, basically how well they mesh together, how much energy is released when they collide, or when they fit together. And so that's when I figured out that I could try to modify the actual cancer drug to see if I could possibly reduce the binding energy and make it a better fit, because if the cancer drug and DNA if it has a better fit, then the drug is obviously going to work better. And so that's where my project started. And so from there I started thinking of a hypothesis and a proper procedure in which I could follow, because I think that's the most important thing you can do in a science fair project or any sort of research, is that have a very strict procedure in what you're going to do, very meticulous, very structured. And so I decided that I would follow this routine way of experimenting the drug with the DNA, finding its binding energy, then modifying the drug a little bit, then checking that binding energy, then modifying the drug a little bit more, and seeing how that affected the binding energy. And from this, I created a lot of different variations of this drug, and then with it, the binding energies with the DNA. And so I figured out one structure that gave the lowest binding energy. And from there, what I did was I put the structure through a different program on the computer, which gives you biological properties, like how this drug would theoretically interact with the blood-brain barrier, or with your kidneys, or how well would it permeate through your skin if it fell on your skin or something. And so with this new variation, I actually discovered that theoretically it is less toxic than the original mitoxantrone drug, and it's 80% more efficient than the original cancer drug. And so that's what my science fair project revolved around, was that I created a new analog of this drug. And that my research basically set up a platform or a basis for future research on this drug. I mean, obviously my research didn't create this new cancer drug in its final stages. It's not some sort of breakthrough in cancer research, but it's a basis for further research. One thing is that in order to do a high-quality science project, you don't necessarily need to go to some lab or talk to a professor at a university. You can really do everything at your house or using things around your area or in a store or something. You don't need to go to some fancy lab. For example, I did my entire research on my home desktop computer, and occasionally when I needed more computing power, I used the Alabama Supercomputing Authority's supercomputer, but through the internet. And so what I did was I just sent an email to them saying, hey, can I make an account? Can I use your software electronically? And so basically I set up a portal so that my computer would use their computer electronically. And so the point is that you don't really need to start off by talking to a professor and trying to get in some really fancy lab and doing some really complex research, because what the judges are looking for is that you did the work and you yourself did quality work with respect to the resources you had. And if you came up with the idea yourself and you went from ground zero all the way to the top by yourself, and that's where the real points come in. And so I think that's something really important to keep in mind, is you don't need fancy equipment, you just need good ideas.